So 6F is Arithmetic Series. Okay. So before break, we just talked about series in general, and you remember how like everything was really long and we had to write out all the terms and all that? Well, we're kind of done with that, so that's nice. Did everyone write their step backs? So I'm going to start with sort of recapping things that you already know. So arithmetic series is the sum of the terms in an arithmetic sequence. So if we know a sequence is arithmetic because we can either tell or we were told that it's arithmetic, we can actually find the sum of the terms in a finite arithmetic series. So we are not going to add up all the terms to infinity. Like that would just be infinity or negative infinity if we're going that direction. But we can add up a certain amount of terms. So we can add up like the first 12 terms, the first 25 terms, the first 50 terms, whatever it happens to be. So again, it has to be finite, a certain number of terms. And we have two different formulas, which we've briefly looked at, but we'll look at again. But some things to remember. We talked about this on Tuesday before break, that capital S means sum. So the S sub n, let's say it's the first 25 terms, I would have S sub 25. Just like before, the U sub 1 is the first term, and D stands for common difference, so those things are exactly the same. N changes a little bit, not much. N is still the term number, but it's the last term number. Because in this case, when we're adding up a finite number of things, it's going to be the very last number. So if we are adding up the first 25 terms, then this would be 25. Now U sub n, we've talked about how it's a term, but in this case, it will be the last term. So if we are adding up the first 25 terms, U sub n is the number that's in the 25th spot. So the meaning doesn't really change. We just kind of think about it just a little bit differently as we go through with these formulas today. Okay, looks like we're all good. So here's the short formula, if you will. So if you know the first term, the last term, and the term number, you can use this shorter formula. Again, it's in your packet. We already looked at where it was. You probably saw that I had that little chunk underlined. So you have to have the term number divided by 2, and then the first term and the last term. And then you can just plug all of these numbers in, and then you can evaluate that. I find that I like this one. It's visibly shorter, right? Like, I like it, and pretty much I use it if I know the last term. Like, if I know the very last number in my list, I'm going to use this one. That is my personal preference. It is possible to use the other one and still get the same answer, so I'm going to throw that out there. But for me, if I know the very last number, I'm going to find a way to use the short one. That's just how I roll. Everybody got that down? So for the longer formula, you have to know the first term, the common difference, and the term number for the last term. So you don't have to know what number is in that spot, but you need to know how many numbers you're adding up, and then you plug those in. So you use the term number twice. So again, like I was using that example, like let's say it's the 25th term, you would plug that in. You would plug in your first term, and you would plug in your common difference. So if I know those three things, I usually just use this one. Like, yes, I could do some extra work and I could use the short formula if I wanted to. It's true, I could. But if I have those three things, I usually just go right to this formula. Or yeah, another way to think about it is like if I don't know the last term, then I probably just use this one. And everyone did find them in their packet, right? We all know we don't have to memorize them. They're right there for us. Okay, so I've already mentioned this, but the term number is needed no matter which formula you use. Like if you don't know the term number, in other words, if you don't know how many numbers you're adding up, you don't know if it's the first 25 or the first 100, you have to figure that out. So you may need to use the sequence formulas to find the other information needed for the series formula, because you have to have n. If you don't have it, you've got to go back to that other formula and figure it out. Okay, are we ready for, nope, not yet. We've got just 3 examples, so should be a nice way to ease back into everything here. What? Absolutely. All right, so example 1 is find the sum of this series, 1 half, plus 3, plus 5 halves, plus, and so on. We're going to keep adding a bunch of numbers until we get to 50 terms. So we're going to add the first 50 numbers in this list. Yeah, we don't know what the very last number is, but we know it's going to be the 50th number in the list. I know that I'll stop after the 50th number. So the way I approach this is I take a look at like all those different sort of variables that I need. Like I need to know the first term. I need to know the term number, no matter what. Let's see, maybe common difference, maybe the last term. Now I don't need both of these. I really only need one of these two, right? The common difference and the last term, but I'm just writing them both down just to kind of get you to think about those are the things we should look for. We should look for these 4 things, so we might not have them all. So what's my first term? 1 half. What's the term number? In other words, this is how many things are we adding? 50, so that's the term number. I think I can figure out the common difference. 2 1/2. And I would either use the decimal or I would use the mixed number. I prefer not the mixed number, I'm sorry, or the improper fraction. I would not use mixed number. So I don't care which one you want to use. I don't know the last term. So this is where I would say to myself, I don't know the last term, so I'm just going to go with the long formula because you don't need the last term for the longer formula. Is this kind of making sense so far? Like how we know when to use what? So, the longer formula, it looks like this. So I'm just going to write it, and I'm even going to look back at it so that I don't make a mistake here. So it's n over 2, and then I have 2 times the first term plus n minus 1 times the common difference. So that's the exact same formula that we wrote down. So again, since I don't have the last term, I'm not going to use the short formula. And then I just plug these in. So the sum of the first 50 terms, S sub 50, is equal to 50 divided by 2. 2 times 1 half is my first term, plus 50 minus 1 times 5/2 or 2.5, depending on if you're going improper fraction or decimal. So of course it's important that we put everything where it needs to be. Are there any questions about that, like how we have it set up? Because after that, then you do have to really remember your order of operations. Like, don't forget PEMDAS and start going out crazy, okay? So I can do 50 divided by 2. That's fine. That's 25. I can multiply this. That's not going to really change anything. I have to subtract what's in the parentheses. That's 49. And keep in mind, this parentheses is times by the 5/2. Like, keep in mind that's a multiplication there. I think the most common mistake that I end up seeing happens on the next step, and that's where people want to add this, but remember we do have to do this multiplication before we can add a bunch of stuff up. So I end up with 25, and then 1 plus 49 times 5/2 is 122.5. So just keep that in mind. Make sure you're multiplying that out before you're adding. Now I can add up what's in that bracket. So 25 times 123.5. So the sum of my first 50 terms here is 3,087.5. Can you imagine if this was before break and you had to actually find all 50 terms? And add them up?
I would cry.
That'd be terrible, right? So, we did that. I mean, I didn't make you do any up to 50, right? I think I went up to 15 as the maximum there. But are there questions or concerns? Okay. So then we're going to get another example here. Same directions. Find the sum of, but in this case, my series is 8. Plus 10.5, plus 13, plus 15.5, plus a whole bunch of stuff I don't even know, plus 83. So I can really start this with the same approach as before. I can look for those 4 things. I might not have them all. I might not need them all. The first term, the term number, the common difference, and the last term. So hopefully you guys notice that I'm taking that same approach. So what's the first term? 8. What's the term number? How many numbers are in my list? Oh, I don't know. Which we absolutely need that, so we're going to have to do some extra work to find that no matter what. What is my common difference? 2.5 or 5/2, either way. And what's my last term? 83. So, like I've mentioned, you don't have to use the short formula here, but I just want to because I have the last term. So I have to do some work first, so I'm going to do some work in the meantime, but I have that, so I'm going to get set up for the short formula. Right? It's just so short and cute, right? Am I the only one?
Than the one we had last
That really likes it? Okay. The short formula. I'm just all about that short formula. So that being said, you don't have to use it. If you are nope, I don't want to do it, you could use the long formula and you'll get the same exact answer as we do. Either way, regardless if you want to just stick with the long formula or not, we have to find n. So in order to find n, we're going to have to use that formula we already talked about before. So u sub n equals the first term plus n minus 1 times the common difference. I kind of got squished in my space. But if you can't read that because I got squished, where did you find that? The packet, right? We already looked at it today. So perfect, I can fit all of these numbers in here. So u sub n is 83. My first term is 8 plus n minus 1 times 5 halves, or 2.5, whatever you got there. So now I know that every single one of you has the skills to figure out what n is. Besides the fact that we've already done this, we did this in section C1 when we learned first about arithmetic sequences. I'm going to subtract 8, so I've got 75 equals n minus 1 times 5 halves. Now, it is absolutely true that we can distribute 5 halves, but does anyone know a different way we could do it? Okay. Yes. So when I did my work, I distributed by 5 halves. You totally can, but I sort of thought about this today and thought it would be nice to mention it. But you can divide by 5 halves, and if we divide by 5 halves, that's the same as multiplying by that reciprocal, right? I don't know why I want to go for that green. There's no way to read it. So I could times by 2/5, so I end up with 30 equals n minus 1. Now again, you can distribute. If that's making you all like itchy, then don't. So then if I add 1, 31 equals n. Now that we have that, we can go ahead and plug in the first term, the term number, and the last term into our formula. So we're going to have 31 terms. So I have 31 divided by 2 times 8 plus 83. N is the last term number. So how many terms are in our sequence? No, that's a good question. You're asking it. So n is like how many terms. There are 31 numbers. I know we can't see all 31, but there are 31 numbers in this list. So I end up with 15.5 times 91 when I add up the 8 and the 83. So what do I got here? I've got 1,410.5. So the sum of that series, those 31 terms, is 1,410.5. You're going to just do one more. Are there concerns? Anyone feeling funky about the two formulas? Does anyone have a preference? Like, I really like the short one, or I really like the long one? Who really likes the short one? Who really likes the long one? No shame. Okay. Yeah?
Where did that 45 come from again?
45?
There's like right in front of your face, like directly in the middle.
No, that's 2 divided by 5.
Oh, it's 2
Oh, okay.
fifths.
Alright, yeah, I was wondering why there was a 45.
I was just multiplying. And you don't have to do that. You can distribute the 5 halves and get it by itself.
Yeah.
Okay?
Cool.
I just wanted to bring that up as like an option just to kind of remind you guys. But like if you look at my notes, I did the distribution thing and it takes a few more steps, but there's nothing wrong with it. Okay. So sigma is back, right here. We'll be okay. So same directions, evaluate the arithmetic series. And we've got sigma, we're starting at the first term. Wait, what does this 15 on top mean? The 15th term, so that's the last term is the 15th term. And then our little formula is k minus 50. So it's a really big deal that it tells us that it's arithmetic. It saves us some time. We don't have to do a few terms, because you pretty much have to do like 3 terms to figure out if it's arithmetic or geometric. You kind of have to take it out to decide. But yeah, sigma could be...
No, I mean, like, it tells us within it right away whether it's geometric or...
Maybe, if you really know what you're looking for. Then it does. We haven't talked about that too much, though. But it tells us here it's arithmetic. So we can honestly kind of keep the same approach we've been having. We can look for the first term, the term number, maybe the common difference, or the last term. We can still keep that approach. Even though this looks completely different, even though this is not a list of numbers, I can still take this approach. It might just take a different way to get here, but we can get here. I think right off the bat, we only know one of these. We know how many terms we're adding up. How many is that? 15. So remember that number on top is n. That's how many terms you're going to add up. Yeah, to find the first term, since we're starting with k equals 1, I just got to plug 1 in. So I'm going to do some work. My first term is 1 minus 50, which is negative 49. Okay, that's not too bad. Now, I did see more hands go up for short formula, so I'm going to go the short formula route here. You could go both. So the last term is in the 15th spot. I can find the last term by plugging in 15. So that'll be my last term. So I can do 15 minus 50, which is negative 35. So now I actually have everything I need for the short formula because I don't need the common difference. So I can do the sum of the first 15 terms is 15 divided by 2, and then negative 49 plus negative 35. I didn't actually write the formula down. Is that okay? We're not figuring out our. Usually I like to write it down. So I end up with 7.5 times negative 84. Yep. So the sum of the first 15 terms is negative 630. So just for those people that might be like secretly long formula people, what you could do then is you could just figure out the second term by plugging in 2. So 2 minus 50 is negative 48, and you can kind of think about it. Okay, I've got negative 49, negative 48, so what's the common difference? Adding 1, and then you could use these 3 with the long formula if that's the way you want to go. And let's say it doesn't tell you if it's arithmetic or geometric, I would just make sure you get a third number at least. So if I plug in 3, I've got negative 47. Now I can really see the pattern is adding 1, right? So if I didn't know, like if it didn't say arithmetic, I could take it out to 3 terms to kind of find out, like, okay, it's adding 1. I can go with an arithmetic formula here. Okay, so write down one thing you learned from today's lesson. In other words, what's the first thing you want to see when you turn back to this page in your notes? So you know that test is coming up on Friday, so like if you look back at your notes, like what do you want to see when you flip to this page? I would probably want to see like either the formulas or I'd want a reminder like you need n, you kind of can't remember, you can't forget about that original formula we talked about.
Always need n.
And here is your 6F assignment.